So, related rates, all we're doing, I'm going to talk about like the steps first. All we're doing is finding an equation with variables like that model our situation. So we got to relate all of the variables that we have, all of the changing pieces. Hopefully you guys remember this from last year. You relate all the changing pieces, and then you take the derivative of it so that you get rates, because the derivative is a rate. And then you have an equation that relates all the rates. And then you solve for whatever rate that they're asking for. So the first thing that I would do, this might be different from the order of the steps last year, but the first thing that I would do is write down the rate that they want you to find. So I'm going to read this. A hot air balloon rising straight up is tracked by a rangefinder 500 feet from the liftoff point. At the moment, the rangefinder's angle of elevation is pi over 4. The angle is increasing at the rate of 0.14 radians per minute. How fast is the balloon rising at that moment? So the first thing is, I'm thinking, it needs a question mark. How fast is the balloon rising? I don't even know how to write that rate because I don't have a picture. So I guess the first thing I would do is draw a picture. Are we okay with that? So I'm going to draw a picture. It says a hot air balloon is rising straight up. Okay. Hot air balloon. That's the hot air balloon. Just because. Settle down. And that's the ground. That's the ground. There's the ground. It's going upwards. So this is some distance, and it's moving upwards. And then it says hot air balloon is rising straight up, and it's tracked by a rangefinder 500 feet from the liftoff point. This is the liftoff point if it's going straight up, yeah? So then the rangefinder is like here, 500 feet away. Are we okay with this so far? 500 feet. 500 feet. It finds the range, finds distances. I don't know, probably using lasers, infrared or light. Like, you know how fast light goes, and then see how long it takes to bounce back, and then you know the distance. You do calculations, but anyway, so far are we okay? And liftoff point at the moment, the angle of elevation. So this is the angle of elevation. What do you want to? Well, we'll call stuff in a minute. So first step is to write or draw a picture, and then I would label with variables any piece of this that's changing. So what is changing? So whatever's changing here is theta, or some angle. Somebody said let's call it theta, so I'm going to call it theta. What do you want to call this length? H. Makes sense because it's height. I ask on purpose, I hear what you say, and then I don't do it every single time. Intentionally. No, never mind. So then what? Is 500, is that changing? No, that's not changing, so we don't need to make it a variable. And what is it asking for then? What is the rate that it's asking for? Okay, so how would I represent how fast the balloon is rising? We did it, Reddit. So it's asking for dH dt, because that's the rate at which the balloon is rising. The rate at which the balloon is rising. So should dH dt be positive or negative when we get it? It should be positive because dH dt is growing. If it's growing, it should be positive. If it's shrinking, if h is shrinking, then dH dt should be negative. So this should be positive. That's just something to keep in mind. And then now we need an equation to relate all our variables. How can I relate theta and h? We can use Yeah, SOHCAHTOA. So what is this? Opposite, adjacent, tangent of theta equals h over 500. Yeah? What do you think we do? We have an equation that relates the variables. To get a related rates equation, we need to find out what the rates are. So to get the rates, we take the derivative with respect to t. So I have to take the derivative of this, and I'm taking it with respect to t, d dt of all of this. So what's the derivative of tangent? Secant squared. But I'm taking it with respect to t, so those disagree, yes? So we have to use implicit differentiation. So I get secant squared, so the derivative of the outside with the inside the same, times d theta dt. I'm recording. So, and then I take the derivative of this. It's like 1 over 500 is a coefficient. So the derivative of h is just dh dt. So like 1/500th times dh dt. What do I do next? You solve for dh dt. Do we have d theta dt? What is d theta dt? Yeah, 0.14. What's theta? Pi over 4. So you plug it all in, and then, yeah, multiplied by 500. You do it anyway, yeah? So, what is this? 0.14. I haven't even done this yet. What is secant of pi over 4? That's 1 over cosine. Cosine of pi over 4 is root 2 over 2. So it would be 2 over root 2, right? And then square it. That'd be 4 over 2. It's 2. I don't know. I don't know. So that's 2 times 0.14. And then we'd have to multiply both sides by 500, right? And then I would get dh dt. Whoops. What is it? dh dt equals, you said 140? That makes sense. 1, 2, 3. I'm not good at math. What are the units? What are we finding? It's minutes.
Feet per minute, yeah.
Feet per minute.
Yay.
So let's review the steps, and then I'm going to stop this video because it's so long. The first thing was to draw a picture of what is happening. Yes? Draw a picture. The second thing is... you need to take a nap. The second thing is to label with variables any piece of your picture that's changing. Anything that changes changes value. So that was the h and the theta in this case. Technically, the hypotenuse changed as well, but we didn't have to involve the hypotenuse because we weren't even talking about the hypotenuse. So label anything that's changing. Then write with derivative notation whatever rate you're trying to find. And then write an equation that relates all your variables that change. And then take the derivative so you get an equation that relates the rates. And then solve for the rate that you have by plugging in whatever you need to plug in. Yeah, you shouldn't have just stayed up all night watching Korean television. A police cruiser. You don't have to write this down. You can take a picture or whatever. I recorded enough, so I'm going to stop that.